The second part of today's lesson is going to be another way to calculate delta H. This time it's called the enthalpy of formation. So you'll see a little subscript F that stands for formation. Still at standard state. Definition: the change of enthalpy during the formation of 1 mole of the substance from its constituent elements with all substances in their standard states. So delta H of formation is enthalpy of formation. Now this bottom part right here is really important to remember. If a pure element is in a reaction, there won't be a value for delta H of formation because the element isn't formed, it only exists. So a delta H of formation value is not going to be found for any pure element. So if you've got any metal, calcium, sodium, silver, any gas, any diatomic, I2, H2, N2, any of the Brinkelhoffs, you're not going to find a value of delta H. So if I go here to our data booklet, it's on page 12. It says selected compounds, thermodynamic data. None of these are going to be elements, pure elements. They're all compounds because only compounds are formed. That makes sense? So I'm just going to go ahead and do the same example, the one for methane. Here's methane. Notice this column here is delta H of formation. You see the little F there. So I'm going to use this value, negative 74. So for our example, I'm going to use the same example that we just did for the enthalpy of combustion. Again, I want you guys to see what's happening here. We're using the information from the data booklet, but this time it's for the delta H of formation. So if I go to my paper really quick, let's just go through this. Here is the reaction, carbon reacting with hydrogen gas to form methane. Here's the formula. It's still going to be products minus reactants, same as we did for enthalpy of combustion. From page 12, I'm going to get these numbers. Negative 74 for methane. And again, hydrogen, it's a Brinkelhoff. It's a gas that exists. Carbon, it's a element that just exists. So their values are 0. So when I do the math, I have negative 74 for the products minus 0 for the reactants, and it gives me a value of negative 74 kilojoules per mole. So since it's a negative value, we would say it's exothermic, okay? Notice that the values are almost, we got the same number when we did it this way. We got 75 kilojoules per mole. We got a positive value. And when we did with this one, we got negative 74 kilojoules per mole. It's basically the same value, just one's positive, one's negative. All right?